We're back in it. All right. So the downside, again, is investment time and money. So surveys are awesome. Okay. Surveys can reach tons and tons and tons of people at once. Okay. That's why surveys are so great. So survey is a list of questions answered by research participants. If you have a question, for example, do STDs lower individual self-esteem? We can't give a bunch of people STDs and they'd be like, all right, has your self-esteem been lowered? No, but we can ask questions. So this is very, very, very good way to get huge numbers of people. But the dilemma is 140 people surveyed about prejudicial attitudes. Is that something that's going to be a good survey? No, absolutely not. Especially if you only pluck, 140 people from this tiny little space or area. That's not going to make a good survey. The larger the survey, the better. And across the country, the survey is the better. So like someone may do a study at, in Greenwood, and the study goes well, and they're like, okay, well, let's spread that out a little bit. And they may have colleagues they pass it on to that maybe do it in Atlanta. And then they say, wow, this really went well. I have a friend of mine right now who's doing international studies with perception, but she started in her little local town of France and then moved out, and now she's doing international studies. So it can grow really big, but the more participants you have, the stronger the study's going to be. So if you read a study saying 100 people were surveyed and found that, that's not enough people. It's just really not enough people. All right, archival research. This is one that's grown a good bit. There's a lot of archival research going on right now because we're looking at what was the sleeping level before 9/11, after 9/11, what was the sleeping level the first week of, when you look at COVID-19, the first week of that versus the fourth week of it. What are the differences there? What is going on in society now? So we look at things like that for archival research to compare what's going on now with what was. It portrays the portrayal of aging in birthday cards. So, if you notice birthday cards, the way they, you start with something adorable and cute, and as they move up, you see differences in ages of cards. So you've got to be careful with archival research because it doesn't necessarily show the cohort that is now. So a great example of this is if you go back and look at research from 1950 about mate selection. All right, excuse me, I'm writing with a mouse, guys, but 1950 mate selection. All right, so it's going to be way different than 2020 mate selection or what people are looking for in a partner. It's going to be very different. So we don't want to compare that 1950s research to say this is how it is now. Prejudicial attitudes going back to 1920, alcohol use going back to 1920 during Prohibition. Do you see what I'm saying? Like, you need to be careful with archived research because you may be able to pull research out from 1984 that says individuals think this, but it is not what they think now. It is completely changed or different. So you've got to be careful. Also, there's really no insurance on how that research was gathered because especially if you can't contact the researchers or things like that. So you got to be careful with archival research, but it can be helpful, especially when you're doing comparisons. So, all right. So longitudinal research. This is where research design, data gathering over a number of years. You can do cross-sectional or longitudinal. Cross-sectional is when you ask a group of 30-year-olds, or excuse me, a group of 20-year-olds, and then you ask a group of 30-year-olds, then you ask a group of 40-year-olds, and you ask a group of 50-year-olds, and then you compare them, okay, to see if there's differences. Now, there's some problems with this because of cohorts. So, like, a 20-year-old now is going to think differently than a 50-year-old because, A, a 50-year-old is matured, right? But also, the 50-year-old has had different experiences than that 20-year-old, okay, when they are 50. So longitudinal is a way better way to get this. This is where you study a group of 20-year-olds, then you ask them again when they're 30, then you study them again when they're 40, then you study them again when they're 50. And then you come to your conclusions. Then you do your conclusion right up at the end of that. Okay? This is comparing these, coming to a conclusion, and this is following the age and then coming to a conclusion. So longitudinal is way better, obviously, because this group of 20-year-olds are experiencing having the same experiences. Okay? In my textbooks, they were talking about 9/11 being, 5 years ago, 9/11 being a flashbulb memory. Everyone knows where they were. Well, college students, some of you weren't born when 9/11 happened. So it's not really something that's applicable in the classroom necessarily as talking about it being a flashbulb memory. But people who were born during 9/11, who were alive, who do remember it, they may have kind of a different view of thinking that may go up with them till they're 50. So following the same group of individuals is very helpful to get more accurate idea of how people develop. But it's really costly. It costs a lot of money. So instead, we would look at 20, 30, 40, 50-year-olds and then see kind of compare and contrast differences. All right, so two types of research. You have correlational and experimental. Correlational research means there's a relationship. So this shows no cause, okay? There's no cause. There's no cause in correlational research. It's A has relationship A has a relationship to B, okay? Just A has a relationship to B. That's the big thing. A has a relationship to B. Not A causes B or B causes A. A has a relationship to B, okay? This is done by investigating both variables, your two variables, and then getting a correlation coefficient. Now, correlation coefficient works on a number strand like this. You have your -1, +1, okay? And then you have 0. 0 means no correlation. Okay? There's no relationship between the two variables. None whatsoever. That's what 0 means, okay? -1 means strong, +1 means strong. The sign, the negative and the positive signs, the sign shows direction. Okay? The sign shows direction. A positive correlation means that the variables are going in the same direction. Okay? The negative sign means the variable is going in opposite directions. So if I say, for example, the more I exercise, the more weight I lose. The more I exercise, the more weight I lose. That is a negative correlation. Even though it's like, yeah, but it's good. That's good. We're proud of you. Yay. Even if it's a positive statement, it's still a negative correlation because they're going in opposite directions. So when you see a test question that says, the more Billy drinks, the fuzzier his vision gets. The more he drinks, the fuzzier his vision gets. They're both going in the same direction. They're both increasing, right? Drinking, getting fuzzy vision. They're both increasing, so that makes it a positive correlation. Even though it's a bad thing, it's still a positive correlation. All negative and positive show is sign. The number is direction. The number shows strength. Okay? So the number shows you the strength. So if you have a negative 0.5 correlation and a positive 0.5 correlations, they have the same strength. Even though in your math class, negative 0.5 is lower than positive 0.5. It is not with correlation. Sign only shows direction. So this is saying that we have a correlation that goes in different directions. This is saying we have a correlation that goes in the same direction, but they're the same strength. Okay? The number shows strength, and the sign shows direction. All right? We good? All right. Pretty good, pretty good. So, one of my favorite correlations is ice cream, and drowning. We found a correlation that the more ice cream people consumed, the higher the drowning, the more likely they were to drown. This is a positive correlation, and it's a very strong correlation. But the problem with this correlation is, when do people eat ice cream? Can I open my text box from here? Oh, yes, I can. So where does it go, though? Chat. I don't know where the chat box goes. I cannot see my chat box. No. Where's my chat box? Okay, I can't see the chat box. But when do people eat ice cream? In the summer, right? Right. They eat ice cream in the summer. When do people swim? In the summer. The more you swim, the more people that are swimming, the more drownings we have. It's a pretty strong correlation. The more people are swimming. So it's not that ice cream is causing people to drown. It's that we see that the more people swim in the summer, the more people are also eating ice cream in the summer. And we made a correlation, a relationship. But it doesn't actually exist. It's what we kind of call a fake correlation, or a mock correlation, or a correlation that it's just not true. It's not real. All right. So yeah, why does this occur? Confirmation bias. When we believe something to be true, we seek supportive evidence and ignore non-supportive evidence. Like car shopping, for example. If we believe this is the safest car on the market, we kind of ignore everything else, and we only look at what's being printed about it, like little things. So that's one of the things with correlational research. You got to be really careful with correlational research, because it's the kind of research that people use to be trickery. Like, I see in magazines all the time, a relationship between, how often your spouse brings you flowers and whether or not they still love you. It's like that. There's no correlation there. There just isn't. Or cheating on you. If your spouse brings you flowers, they're cheating on you. It's like you can't win either way. You know what I mean? So you got to be careful with correlational research. The research that was done that said, 9 out of 10 dentists choose Crest. Well, yeah, 9 out of 10 dentists chose Crest, but guess what? They chose Crest on a cruise that Crest sent them on. I'm going to choose Crest too, right? Let me see if I can find my chat bar, because it looks like some of you are typing, and I'm worried that you're typing and I'm not getting it to chat to me. So hold on. Let me see if I can find it. Oh, there it is. Oh, no. Okay. All right, but I did find it, so that is good. Yay. All right, so put this back up. Nope, I need this guy. All right, so good deal. So I can see the chat now, so we're good. All right, so let's go back. Wow, I didn't like that at all. Too fast. It said too fast. All right. Okay, so that's correlational design. So experimental design. Experimental design, okay, is when we are saying A causes B, all right? So experimental design, we are absolutely showing cause, okay? So we are showing cause in experimental design. The most basic design has two groups, okay? So you have two groups. You have a independent variable and a dependent variable. And we'll talk about those in a second. You want to operationally define what you're studying in the experiment. So for example, and I do this with my class, for example, if I'm going to study love, okay, or I'm going to study love, or I'm going to study love, all right, big difference between those three. Just how I say it makes a difference between those three, right? Love versus love. Those are two different things, right? So when we think about those two concepts, or those three concepts really, puppy love, friendship love, and then, lusty love, they're very different things. So if we're going to study love, we have to operationally define. We have to say what it is we're precisely studying. How do we define love? So one way that researchers define love is proximity, eye contact, communication, anxiety when apart. That's for attachment more so. But that's kind of how we define love, okay? And then you also have to look at experimenter bias. This is where you have your single and your double blind type of studies. Try to avoid that experimenter bias. And then the placebo effect. This is where the expectations influence the outcome, okay? So in our design, we have an independent and a dependent variable. The independent variable is what you manipulate. So you manipulate the independent variable. So if I'm going to say that smoking marijuana slows reaction time, okay? Or let's do my smart pill. Let's do a smart pill because you have an assignment that's going to be due open up next week. That's about an experiment. So let me do a smart pill. So I've got my smart pill, okay? Just taking the smart pill make people smarter. That's what I want to show, okay? So my independent variable is going to be my smart pill. Whether people get this smart pill or not, okay? My dependent variable is going to be the test that I give, the results of the test I give them. Okay? So I give, I have 3 groups. I have my control group that gets nothing. Then I have my placebo group that gets a Skittle. And then I have my experimental group and they get my pill. Okay? So they get my pill. They get a fake pill. And the control groups gets nothing. Sorry, I'm writing with a mouse. I'll put placebo there so you know it's placebo. This is experimental group and this is control group. Okay, so I give the pill to my experimental group and then I test them, and let's say I get my control group gets an 85, my placebo group, I don't look at their score yet, but my experimental group gets a 96. Okay, so I can say, hey, my smart pill made people smarter, right? Because my smart pill caused people to be smarter. My dependent variable is the measure on the test. My independent variable is my smart pill. But if I come in here and I look in my placebo group, if they made a 94, that means my smart pill did not work because these aren't statistically significantly different. So right? So that's why you have that placebo group, because did just taking anything make people feel like they were smarter so they did better? Maybe. All right. You want to have a random sample, meaning every person in the population has a chance of being selected, and then random assignment. You don't want to look out there and be like, oh, that group looks pretty smart. I'm going to put them in my take the smart pill group because, I want my smart pill to be great. So, but no, you want everyone to have an equal chance of being put into experimental or control or placebo group. So reliability and validity. Reliable. When something is reliable, that means it's consistent. Okay? That's all it means, is I'm going to get the same results every time. Okay? So if I get on a scale and it tells me I weigh 110 pounds and it says it every single time, good morning, Meredith, you weigh 110 pounds. And just so you guys know, I do not only weigh 110 pounds. I weigh more than that. But if the scale says I do every morning, it is reliable. It is reliably telling me every morning. But is it valid? No. It is not telling me the truth. If I wake up and get on the scale and it says, good morning, you're 5'10" or you're 5'9" inches. If it tells me every morning that I'm 5'9", it's giving me my height, but it's not measuring what it's supposed to measure. Validity is about the truth. This is saying it's accurately measuring what it's supposed to measure. So if I get a test for depression out and everybody tests depressed or everybody tests anxious, if I do an anxiety test, am I really measuring for depression and anxiety? Is that test really actually valid? Even if I get the same results every time, is it valid? Is it really measuring, like the SATs, is it really measuring a person's ability to do well in college? Only about 8% of the time, which you know, we find that people that don't do well in SATs do great in college. So now we find people that do well in SATs also usually do well in college. So there is an association there. But there's not necessarily an association with people who don't do well. They go on to succeed and do quite well, actually. So it's not really a good measure. It's not really valid. It's not measuring what it's supposed to measure. It's not measuring academic efficacy. It's not measuring motivation. It's not measuring drive. It's not measuring any of that, okay? So for a measure to be valid, it has to be reliable. But to be reliable, it doesn't have to be valid. So you can get the same result every single time with a test you give, but it doesn't mean it's not valid. But to be valid, it must be reliable, okay? All right. So with regards to ethics in research, well, with human beings, we have an IRB board. And the reason we have this IRB board is, well, because many times, often than not, research has done things that they probably shouldn't do. There's plenty of studies out there that cannot be recreated because they were unethical. So IRB boards were formed to say, we're not going to let you give a whole bunch of people a disease just to see what happens, all right? You're going to have to actually roll that back. You're going to have to find a different way to study this. Sleep, for example, you cannot do a study on sleep, keeping a person awake more than 24 hours, because it's actually considered irreparable harm for a person to stay awake for more than 24 hours. So it can do actual damage to the brain. So you ethically can't do a study. All right, informed consent. A person must be informed of what's going to happen and have consent. You can use deception in a study, okay? You need to make sure to mention this too when you use a placebo in the study that you guys are going to do with the apple and being smart. All right, so you have to debrief the person, meaning you tell them the purpose of the experiment, why it was done, and why deception was necessary. After the experiment's over, you debrief. With animal research, often rats or mice and birds are used for research subjects. It's considered substitute research that would be unethical, be done on humans, but there still has to be a good reason. Like, you are not going to be able to study a rabbit with I've got a new hairspray that I want to put on the market. They used to spray it into bunny's eyes to see what would happen. That's not ethical research anymore. That's not allowed. So it's not something that's going to get past a review board because we have plenty of hairspray on the market. There's plenty of makeup on the market. So using animals for that sort of research is not something that we say okay to anymore. So the IACUC, Institute of Animal Care and Use Committee, is basically the animal research IRB. So if someone wanted to do research with animals, they would have to go through that Institute of Animal Care and Use Committees. And there's certain things you have to do and ways the animals have to be treated and contained. So, all right. So that is my lecture for the day. Is there any questions? You guys got anything you'd like to ask me? I'm going to stop the recording though, so it doesn't get too long, but